Ever wondered why your heart pounds when you're scared, or why you want to run away from something that terrifies you? It's a common experience we all share, this sensation of fear. It's a primal and powerful feeling that can overtake us in an instant. But what is happening in our bodies and brains when we feel this way? What is the science behind these intense emotional responses? These are intriguing questions that touch the very essence of our human experience. Well, let's dive into the fascinating world of the physiology of fear. Fear isn't just an emotion, it's a complex physiological process. To understand fear, let's embark on a journey through the human body. Picture this: you're walking down a dark alley and suddenly you hear a rustling sound behind you. Your heart starts racing, your palms get sweaty, and your muscles tighten. What's happening here? Well, this is your brain's way of preparing you for what it perceives as a threat. The star of this show is a tiny almond-shaped part of your brain called the amygdala. The amygdala is like the lookout tower of your brain. When it senses danger, it sends distress signals to another part of your brain, the hypothalamus. The hypothalamus is like the command center of your brain. Upon receiving the distress signal from the amygdala, it activates a series of hormonal responses. It sends signals to the pituitary gland, which in turn signals the adrenal glands to release hormones like adrenaline and cortisol. Adrenaline increases your heart rate, blood pressure, and energy supplies. Cortisol, often referred to as the stress hormone, suppresses non-emergency bodily functions like the immune response and digestion, prioritizes the functions that would be most useful in a fight or flight situation, and regulates the energy supply by tapping into the body's fat, protein, and carbohydrate reserves. This hormonal cascade results in the physical symptoms we associate with fear: quickened heartbeat, rapid breathing, and heightened alertness. It's like your body is preparing for a sprint race, except the finish line is survival. What's more, these hormones also affect memory formation, ensuring that we remember dangerous or threatening situations and can respond more effectively if they happen again. So, fear isn't just in your mind, it's a full-body experience. Now meet the amygdala, the star of our fear response. Nestled deep within the temporal lobes of your brain, this almond-shaped bundle of neurons is on constant high alert, acting as the sentinel of your survival. When a potential threat enters your sensory radar, be it a hissing snake or a looming deadline, your amygdala springs into action. It's like a vigilant scout, always on the lookout for danger, ready to sound the alarm at the first sign of trouble. It's here in the amygdala where the initial fear response begins. Upon detecting a threat, the amygdala sends a distress signal to another part of your brain, the hypothalamus. This is akin to pressing the panic button, triggering a cascade of physiological responses designed to prepare your body for action. This is where the concept of the fight or flight response comes into play. It's a primal instinct that dates back to our early ancestors, who needed to react swiftly to life-threatening situations. In a split second, your body must decide whether to stand your ground and fight or to take flight and escape. But the amygdala isn't always accurate in its threat detection. Sometimes it can mistake a harmless situation for a perilous one, sending us into a state of fear or anxiety over something that poses no real danger. It's like having a highly sensitive smoke detector that goes off when you're just making toast. Despite its occasional misfires, the amygdala plays a critical role in our survival. It's our brain's early warning system, priming us to respond to danger. It's the reason we jump when we see a shadow in the dark, or why our heart races when we hear an unexpected noise. So the amygdala is like the alarm system of your brain, always on the lookout for danger. Let's talk about cortisol, the stress hormone. Now, when the amygdala sends out its distress signal, it doesn't just stop at triggering adrenaline. It also lays the groundwork for the release of cortisol. This chain reaction of hormonal release takes a scenic route from the hypothalamus down to the pituitary gland and finally to the adrenal glands, where cortisol is released into the bloodstream. But what role does cortisol play in the fear response? Well, think of cortisol as your body's emergency power supply. When the alarm bells ring, cortisol is the one that flips the switch, powering up your body for the impending threat. It does this by metabolizing fats, proteins, and carbohydrates, converting them into usable energy. This energy is then directed towards essential functions that aid in survival, heightening your senses, quickening your heartbeat, and preparing your muscles for action. While adrenaline is like a sprinter, providing instant bursts of energy. Cortisol is more of a marathon runner, ensuring that your body remains on high alert and continues to function efficiently even if the threat persists over a longer period. But just like a car can't run on high gear all the time, our bodies aren't designed to be drenched in cortisol constantly. Chronic exposure to cortisol can lead to a host of health issues, including anxiety, depression, heart disease, and memory impairment, to name a few. So, while cortisol in the face of fear is a lifesaver, ensuring we have the energy to either face the threat or make a quick exit, it's essential that once the threat has passed, our cortisol levels return to normal. This is where the prefrontal cortex comes into play, helping to regulate our fear response and bring our bodies back to a state of calm once the danger has passed. Cortisol is like your body's emergency fuel, powering you to face or flee from the threat. Our amygdala also plays a key role in fear conditioning. Now, what does this mean? Let's dive in. Fear conditioning is a process where we learn to associate certain stimuli with threats. This is a basic survival mechanism, hardwired into our brains. Imagine you're walking in the woods and you see a snake. Your amygdala springs into action, triggering a fear response. This is your brain's way of keeping you safe. The amygdala has learned to associate the sight of a snake with danger. This is a simple example of fear conditioning, but fear conditioning isn't always that straightforward. Sometimes, the amygdala can learn to associate harmless things with threats. This can happen due to traumatic experiences or even repeated exposure to certain stimuli. For instance, if you have a scary encounter with a dog as a child, your amygdala might learn to associate all dogs with danger. This could lead to a lifelong fear of dogs or cynophobia. This is where things can get tricky. While fear conditioning is a crucial survival mechanism, it can also lead to phobias or anxiety disorders. The amygdala can overreact, triggering fear responses to things that aren't really threats. This is like a misfiring alarm system causing unnecessary stress and anxiety. But here's the good news. Just as the amygdala can learn fear, it can also unlearn it. This is the basis of many therapies for phobias and anxiety disorders. Through techniques like exposure therapy, cognitive behavioral therapy, and others, we can retrain our amygdala. We can teach it to associate the stimuli that used to trigger fear with safety instead. So, our amygdala can learn fear, but it can also unlearn it. That's the basis of many therapies for phobias and anxiety disorders. This shows us that fear isn't a fixed state. We have the power to change our responses, to rewrite our fear responses, and ultimately to live free of unnecessary fears. Fear can be uncomfortable, even paralyzing, but it's not all bad. This might be a surprising statement to some, but fear has its purpose. It's a fundamental part of our survival mechanism, honed over millions of years of evolution. Our ancestors who were better at detecting and responding to threats were the ones who lived to pass on their genes. It's the amygdala, our brain's fear center, that makes this possible. By triggering a chain reaction of hormones, it prepares our bodies to either fight the danger or flee from it. This is the well-known fight or flight response. It's an automatic reaction, one that happens before we even have a chance to consciously process the threat. But fear is more than just a primitive survival tool. It also plays a crucial role in our learning and memory. Fear conditioning, as it's called, allows us to remember and avoid dangerous situations in the future. It's a form of learning that's vital for our survival. Now, it's true that fear can become a problem when it's out of proportion to the actual threat, or when it's triggered by the wrong things. That's where understanding our fear response comes in. By recognizing what's happening in our bodies and our brains when we feel afraid, we can learn to manage our fear response better. We can train ourselves to respond to fear in a more balanced and adaptive way. So while fear can be uncomfortable, it's also necessary. It's a part of us woven into the very fabric of our being. It's a tool that our bodies and our brains use to keep us safe, to help us survive. Fear, then, is not our enemy. It's a survival tool, one that we can learn to wield effectively with understanding and practice.